It's me again. Below is an example of a multi-unit process. The problem involves the production of potassium nitrate, crystals of which are produced in stream C at the bottom of the diagram. The feed is joined by a recycle, before entering an evaporator, where water is removed as a pure vapor. This happens at a high temperature and low pressure, increasing the salt concentration to 50%. Then the concentrated solution is fed to a crystallizer, which operates at a lower temperature, to produce the crystals. In this course, you need to understand and follow the instructions in the problem. You are first asked to perform a potassium nitrate balance over the whole process, hence you first have to draw a dotted boundary around the whole process. You will be reminded how to do the salt balance over the whole process in the next slides. In the problem, you are also asked to do a total balance over the crystallizer, and a salt balance, also over the crystallizer. For this, you have to first draw a dotted boundary, this time around the crystallizer. Your first task is to do a salt balance for the whole system, using the general balance equation. You need to consider each of the terms in this general balance equation, and think carefully what each means. Assuming you have steady state, there is no accumulation of salt in the system. Potassium nitrate salt enters the system, defined by the red dotted boundary, via the 10,000 pound per hour feed stream. Salt comprises 20% of the stream, so the total pounds per hour need to be multiplied by 0.2 to get the salt going in. Two streams exit the red dotted boundary, W and C. W contains only water, so the salt only leaves via stream C. As the feed to the plant contains only water and the salt, stream C should also contain water and salt. The mass fraction for water is 0.04, hence the mass fraction of salt should be 0.96, as the sum of mass fractions should equal 1. No reaction takes place in the system. There only is a physical removal of water associated with the salt. Hence there is no generation or consumption of the salt. Substituting all this in the general balance equation, the flow rate of C can be calculated. Your second task is to do a total balance for the crystallizer, using the general balance equation. See the question to confirm this. Again, you need to consider each of the terms in this general balance equation, and think carefully what each means. Assuming you have steady state, there is no accumulation of mass in the system. M, in pounds per hour, is the only stream that enters the crystallizer. Two streams exit the blue dotted boundary, R and C. You calculated the value of C in the previous slide by doing a total balance over the whole system. No reaction takes place in the system. There only is a physical removal of water associated with the salt. Hence there is no generation or consumption of the total mass. Substituting all this in the general balance equation, M can be solved as a function of R. Your third task is to do a salt balance for the crystallizer, using the general balance equation. Again, see the question to confirm this. Again, you need to consider each of the terms in this general balance equation. Assuming you have steady state, there is no accumulation of salt in the system. M is the only stream that enters the crystallizer, and the salt will be half of it, as the mass fraction of salt in M is 0.5. M is equal to C plus R, as shown in the total balance over the crystallizer in the previous slide. Two streams exit the blue dotted boundary, R and C. As will be shown in the next slide, the 0.6 mass ratio in stream R translates to a salt mass fraction of 0.375. In addition, the value of C has been determined before, 2 slides back. No reaction takes place in the crystallizer. There only is a physical removal of water associated with the salt. Hence there is no generation or consumption of the salt. Substituting all this in the general balance equation, the value of R, the total flow rate, can be determined. In this slide, you will see how to calculate the mass fraction of the salt in stream R. You are given that, for each pound of water in stream R, you will find 0.6 pounds of potassium nitrate salt. Choose a basis of 1 pound of water. This means that you would have 0.6 pounds of salt. Then you can use the mass of salt divided by the total mass to calculate the mass fraction. Try to do this problem on your own. The answer is given at the end of the problem statement. Press pause and good luck.